Alright, so in this video I'm going to show you how we're actually going to use trigonometry when we're resolving vectors in physics. So remember, a vector is just some quantity that has both a magnitude and a direction. And so we're going to take our vectors and resolve what we call the components. So this vector right here, I'm just going to give it some arbitrary values. Let's just say it's 25 units. And let's say it's at an angle of maybe 37 degrees. And we could describe that in many different ways. We could say that this is north of east, or we could say it's above the positive x-axis. There's lots of different ways that we could state what its direction is. And I then can take that vector and I can resolve what are called its components, both its x component and its y component. So the x component is how far over in the x direction does this vector go, which we could draw by demonstrating that. We can also draw the y component here, and this is how far up it is. So it's sort of like its coordinates, right? So I want to know how much in the x and how much in the y direction is this vector. And if you notice, as I've drawn it here, I've drawn it like a right triangle. So all we need to do is use trigonometry in order to figure out what the sides are. So this is our adjacent side. So I would, in order to solve for the x component, we'll call it Vx. I need to use cosine, right? So the cosine of the angle theta is equal to the adjacent, which would be Vx, over the hypotenuse here, which we could call Vr, or the resultant vector, or whatever. We could give it some other letter, but let's just stick with Vr. So then I just have to plug in my values that I have. So the cosine of 37 is equal to, and then I want to know what Vx is, all over 25. Right? So if I plug that in, I would just have cosine of 37 and multiply by 25. And so I would get that side is about 20, right? We'll just round it. 20 units would be my x component, right? Then if I was going to work my way up, I could use the y component. So the y component is going to be the opposite. So that trig function we would use would be sine. So sine theta is equal to, and we'll call that Vy, all over resultant. Right? So the sine of 37 is equal to Vy, or the y component, all over 25. Okay, so that's about 15. So this is called the component method for determining the x and y components of any vector. Now this vector is in our right, or in our first quadrant, right? So in math we like number these quadrants, 1, 2, 3, 4. In physics, what we're going to do is we're actually going to just always describe our quadrants using words, rather than like trying to figure out, well, am I 180 plus 37 or whatever. We'll use words. So let's just kind of look at that, what that means. I could say this is positive x and this is negative x. Or I can say this is positive y and this is negative y. Or I could say that this is north, south, west, and east. So over here I could have an angle that is going north of east, or above the positive x-axis, and that would be this angle, and my x and y components would both be positive over to the right and up. Whereas if I'm over here in this quadrant, I could say that it is above the west axis, or above the negative x-axis, or north of west, or I could describe it as west of north if I were looking at that angle. But if we look at our components, you can see that they have a direction. They are arrows, just like the vectors are arrows. And we can see that in this instance, my y component is positive, my x is actually negative. Right? Likewise, if I'm down here, now I'm going to have a negative x, and I would also have a negative y. Or if I'm over here, I would have a negative y, but a positive x. Alright, so on the first classwork, you're going to be working with practicing trig review using sine, cosine, and tangent, as well as determining the components of known vectors at specific angles.